Imagine a world so far away that sunlight there is more than 400 times dimmer than on Earth. A place where the sun appears as little more than a bright star in a permanent twilight sky. This is the realm of Uranus, the seventh planet from the sun, spinning on its side as it journeys through the cold expanse of our solar system. Unlike any other planet, Uranus's axis is tilted nearly 98 degrees, giving it bizarre and extreme seasons that last over 20 years each. Its faint rings and pale blue-green color hint at a deep, mysterious interior, but it's the moons circling this planet that may hold the greatest mysteries of all. Orbiting Uranus are 27 known moons, each a tiny world wrapped in ice and rock. These moons range from small, irregularly shaped objects just tens of kilometers across, to larger bodies hundreds of kilometers wide, each one shaped by forces ancient and powerful. Despite their small size, these moons tell stories as epic as those of the planets they orbit. They bear the scars of collisions with comets and asteroids, evidence of volcanic ice flows, and tantalizing hints of hidden oceans beneath frozen crusts. Though often overlooked, these moons form a complex and captivating family. Their existence challenges what we know about planetary formation, moon evolution, and the potential for life in the outer reaches of our solar system. In their quiet orbits, they guard secrets that could rewrite our understanding of worlds beyond Earth. The moons of Uranus carry names drawn not from the ancient myths of gods and titans, but from the rich tapestries of human literature. Characters from Shakespeare's plays, like the ethereal Ariel, the stoic Titania, and the tragic Miranda, join with figures from Alexander Pope's poetry, such as Umbriel, to give these distant worlds a human touch. This literary naming tradition reminds us that exploration is not just about science. It's also about the stories we tell, the dreams we chase, and the meaning we find in the cosmos. Among these moons, Miranda is perhaps the most astonishing. Though small, barely 470 kilometers in diameter, its surface is a shattered landscape of contrasts and extremes. Miranda's terrain resembles a cosmic jigsaw puzzle, with massive cliffs, deep canyons, and strange, polygonal coronae that look like giant fractured icebergs fused together. The sheer cliff of Verona Rupees, plunging miles into the moon's shadowed depths, is one of the tallest known in the solar system, a breathtaking natural wonder. Scientists believe that Miranda's fractured surface may be the result of a violent past, when a massive impact broke the moon apart. Gravity then pulled the fragments back together, creating a patchwork world unlike any other. This moon challenges the idea that small bodies in the solar system are simple, inert rocks. Instead, Miranda reveals a violent, dynamic history, a moon that has been reshaped and renewed, perhaps more than once. Further from Uranus, the moon's Ariel and Umbriel orbit as stark opposites. Ariel shines with icy brightness, its surface etched with fractures and smooth plains that suggest recent geological activity. It may have experienced cryovolcanism, eruptions of water or ammonia beneath its crust, reshaping the surface and hinting at a warmer, more active interior than once thought possible. Umbriel, in contrast, is a world cloaked in darkness. It absorbs almost all sunlight, making it one of the darkest moons in the solar system. Its ancient, heavily cratered surface tells a story of long-standing cold and stillness. This stark contrast between Ariel and Umbriel raises fascinating questions about how two moons formed in the same environment could evolve so differently. Are these differences due to internal heating, compositional variations, or their unique collision histories. The interplay between these moons reminds us that even small differences in conditions can lead to vastly different outcomes, both in worlds and perhaps in life itself. Dominating the Uranian moon system are the giants Titania and Oberon, each nearly 1,600 kilometers in diameter. They are among the largest icy moons in the solar system, large enough to have their own complex geology and possibly hidden oceans beneath their frozen surfaces. Titania's landscape is carved by deep valleys and towering fault scarps, revealing a history of tectonic stretching and contraction. Oberon's surface is older and more battered, covered with numerous impact craters and mysterious dark patches whose composition remains a subject of study. Scientists speculate that both moons may harbor subsurface oceans, pockets of liquid water kept warm by tidal heating and the decay of radioactive elements within their cores. These oceans, if confirmed, could represent some of the most promising locations for life beyond Earth, in an environment so distant and cold that it challenges our traditional notions of habitability. Exploring Titania and Oberon could provide critical clues about the potential for life in the outer solar system, and about how icy worlds form and evolve in the deep freeze of space. Our knowledge of these mysterious moons comes largely from a single brief encounter, NASA's Voyager 2 flyby in 1986. For just a few hours, Voyager 2 soared past Uranus, sending back the first close-up images and data of its moons. The pictures were grainy and incomplete, yet they revealed a world of complexity and variety that sparked scientific excitement and curiosity. Voyager 2's flyby was a fleeting glimpse, a teaser for what awaits if we return. Since then, Uranus and its moons have remained largely unexplored, overshadowed by missions to Mars, Jupiter, and Saturn. But the past decade has seen renewed interest in the ice giants, driven by advances in spacecraft technology and a growing understanding that these distant worlds may hold keys to answering fundamental questions about our solar system. Planned future missions could orbit Uranus for months or years, mapping its moons in detail, measuring their gravity and magnetic fields, and searching for signs of activity beneath their icy crusts. Such missions could revolutionize our understanding, revealing whether these tiny worlds are truly dead and frozen or quietly alive beneath their frozen exteriors. Uranus's moons remind us that in the coldest, darkest corners of our solar system, there are still worlds waiting to be discovered, worlds that challenge our assumptions and expand our sense of possibility. Though small and distant, these moons are dynamic, complex, and rich with stories of cosmic violence, geological renewal, and perhaps even the potential for life. They orbit a planet unlike any other, a planet tilted on its side, spinning silently through the void, surrounded by faint rings in a family of moons that hold secrets millions of miles from Earth. These tiny worlds beckon us to explore further, to listen closer, and to remember that in the vastness of space, even the smallest places can hold the biggest secrets. Uranus's moons are more than distant ice balls. They are frozen archives of the solar system's history, beacons of mystery, and perhaps the next great frontier for discovery.